Okay, welcome back to Calc 2. We're going to talk about L'Hopital's rule tonight. All right, so let me go ahead and share my screen so we can get started with this. All right. So the thing about L'Hopital's, okay, the important thing about L'Hopital's is you have to use it on what's called an indeterminate form. Okay, and what I mean by an indeterminate form is you have to use it on something that looks like 0 over 0 or infinity over infinity. Okay, if you don't have a form that does this, there are some things you can do to kind of hammer a problem into one of these forms. But effectively, if you don't have something like this, like 0 to the 0 kind of a thing, that's another one that's like that. I don't think your book does too many of these. But if you don't have an indeterminate form here, then you can't use this technique, okay? So the idea, right, is if you have the limit as x approaches something, right, which could be infinity, we have f of x over g of x, okay? And we have some kind of an indeterminate form here. The idea is what we're going to do is we're going to take the derivative of the top, we're going to take the derivative of the bottom, okay? This is not the quotient rule, okay? The quotient rule has a f prime of g minus f g of prime divided by g squared. There's a whole thing going on. This is what you wish the quotient rule could be. We just take the derivative of the top, we take the derivative of the bottom. What that's doing is it's telling us where the trend of this is going, it's telling us where the trend of that is going, and we're going to reapply the limit here to see if these trends can tell us what these derivatives are going, and then we're going to say that's where the functions are going. Okay, that's the idea behind this thing. So the other thing you have to realize is that L'Hopital's rule might repeat. Okay, so the idea that you did it once and you got an answer, but your answer looked like 0 over 0 or infinity over infinity means you got to apply this again. Okay, and then recheck it, and then apply it again, and then recheck it. And as long as you get something like this, you got to keep rechecking it until you get an answer. Okay, so that's the pluses and the minuses of L'Hopital's. If you are taking a written test and you do not check for an indeterminate form, it isn't, you are going to get it wrong. I know the answer might look right, but the fact is that you did it when you shouldn't have been doing it, which means it's the wrong answer. Okay, I don't think your book does that too often to you, if at all. Okay, all the problems I saw were very legit as far as not trying to fool you. However, there are problems that are designed to fool you. Okay, so do me a favor, please. The first step you're going to do in a L'Hopital's problem is you're going to say check the form, okay, to see if it's indeterminate. If it is, feel free, but if it isn't, you got to do something else. Okay, so here we go with L'Hopital's rule, and I'm just going to grab a couple of problems from your book and start doing them. Okay, so here we go. Oops, I don't want to do that. You just want to grab this. Okay, so we're going to say limit, right, as x approaches 0 of x to the 5th minus 2x cubed plus 4x squared divided by 4x to the 5th minus 2x squared plus 3x. Okay. So what do we end up with? As x goes to 0, we have 0 minus 0 plus 0. So we have 0 minus twice 0 plus 4 times 0 squared. Okay, and then here we have 4 times 0. Okay, we have minus 2 times 0. We have plus 3 times 0. That looks a lot like 0 over to 0 to me. Check, it's indeterminate. We can use L'Hopital's. Okay, so the next step is apply LH. Okay, so what we're going to do is we're going to take the derivative of the top, take the derivative of the bottom. So that's going to be 5x to the 4th, okay, minus 6x squared plus 8x. Okay, and then divided by, we have 20x to the 4th. Remember, this is going to 0. okay, minus 4x plus 3. Now, when I plug in, right, my limit, so we're going to take the limit as x approaches 0. We get 0, right, 5 zeros minus 6 zeros plus 8 zeros. But on the bottom, we get 0 minus 4 zeros plus 3. So this ends up as being 0 over 3. Well, that's not an indeterminate form. That's 0. Okay. So in this case, right, in this case, the limit here is going to be 0. Right. So that's what we do. Okay. So let's take the next one. Let's take a look. So what do we have here? We have 0, this one. Check the answer and move on with our lives. Okay. Next one. Okay. We have e to the x minus 1 over x to the 9th. Okay. So this is e to the x minus 1 over x to the 9th. And we want to take the limit as x approaches 0. Well, e to the 0, right? That's 1. So we have 1 minus 1 over 0 to the 9th. That's going to be 0 over 0. This is indeterminate. Okay. So let's take our derivative. Okay. So we're going to take the derivative here. This is going to be e to the x. The derivative of 1, right, is 0, divided by 9x to the 8th. We still are taking our limit as x approaches 0. Well, as x approaches 0 for e to the x, that's just 1. Okay. Now, as x approaches 0 of x to the 8th, that's 0. So we end up getting something like we're approaching 1 over 0. Okay. So we're looking at something like this, where this is an even polynomial. So we're looking at something like this, where it's coming in from both sides like this, right? It's even, so we know it looks a lot like 1 over x squared. As we say, x is getting closer and closer to 0. This is getting further and further up. So this is going to positive infinity. Okay? Now let's go check to see there what choices we have for an answer. Okay. I'm going to say this one. Well, let's try it. Okay. They're probably going to say the limit does not exist, but since we kind of know it's going to positive infinity, let's chance it. Okay, but realizing that the correct answer is really the limit doesn't exist. Let's just see how much our book lets us get away with. And it did not like that at all. Okay, so let's go with the limit doesn't exist. And that's much happier. Okay, that's fine. As long as we know what the rules are, we're good. All right. Let's do problem number 5. Double check to make sure I'm not going too long here. Forgot to put my time on. That's great. All right. So let's try this one. All right. So here we have limit as x goes to 5. Okay. Square root x squared plus 24 minus 7. All right. X squared minus 25. Okay. Let's write this as a calculus problem so that if we have to do something with it, we'll know what we're doing. Okay. So this is equal to x squared plus 24 1/2, right? That's what square root means, minus 7. And this is x squared minus 25. Okay. So as we apply our limit, okay, we get 25 plus 24 raised to the 1/2 minus 7, okay, divided by 25, right? 5 squared minus 25. Well, this here, right? 25 plus 24, that's the square root of 49 minus 7 over 25 minus 25. Square root of 49 is 7. So this thing, it looks like a 0 over 0 to me. Right. So it's indeterminate. Okay. Now we're going to go ahead and turn on L'Hopital's rule. Okay. So we're going to say apply LH. Okay. And what do we have? We have the x plus 24 raised to the 1/2 power minus 7. X squared raised to 24, right? divided by x squared minus 25. Okay, so let's go ahead and apply our derivatives. So remember your rules, right? This is 1/2 x squared plus 24 to the negative 1/2 times 2x. You got to remember that chain rule. Okay? Divided by, this is 2x, right? Because there's no chain here. What was my limit? My limit was x approaches 5. Okay, so let's see what happens here. We get the 2 and the 2, that disappears. So we have x squared plus 24 raised to the negative 1/2 power, okay, divided by 2x. Well, I think we can cancel this. Okay, so here we have it. We have x squared plus 24 divided by 2. This is raised to the negative 1/2. Okay, I don't think I could put this into an indeterminate form anymore. So let's just go ahead and do this. So this is 1 over twice 5 squared plus 24. Okay. So what are we ending up with? Oh, to the 1/2. Notice I put it on the bottom, so that took care of this negative here because it went to the bottom. Okay. So this is 1 over twice square root 25 plus 24. So this is 1 over twice square root of what? Of 49. Okay, 49 was 7, so this is 1/14. That was obvious from the start, wasn't it? Okay, I'm kidding you. That's why we learned L'Hopital's to deal with these limits, because these limits are they're kind of crazy, and you're not going to know. Like, what is this limit going to be? No idea. That's why we use L'Hopital's. We check to see if it's correct. And then we go from there. Let's hope I did my arithmetic correct. Okay, fingers crossed. Right, otherwise, okay, great. All right. I'm going to go ahead and finish up doing the harder ones here in the next video for us. This looks like a good one, but because I don't want to make these too long. Okay, so I'm going to stop us here, and then I'll make another one. Okay, so I'll see you in the next video.